All right. Hello, ladies and gentlemen. My name is Anthony White, and I am the Computer Science Content Specialist for the Alaska Department of Education and Early Development. Very excited to have you here today with two leading computer scientists here in the state of Alaska. If you could go ahead and take a minute or two to introduce yourself, and we'll start with Kenrick.
Hi, I'm Kenrick Mock. So I'm currently Dean of the College of Engineering at UAA, but started here as a computer science faculty member way back in 2000 and have been working in computer science since the early 90s and especially around AI, and have been super excited to see where AI has gone today, because when I started working in AI, it was more like the Middle Ages compared to what we've got going now.
Awesome. Great. Thank you, Kenrick. And hand it on over to Frank.
Yeah, hi, I'm Frank Witmer. I'm the chair of the Computer Science and Engineering Department here at UAA. I've only been here since 2014, so Kenrick's got me beat by a few years. Yeah, I got my degree in computer science and mathematics back in the late 90s, and have been involved with a range of uh, different projects. But yeah, well, I'll talk about those later.
Awesome. Great. Well, I'm so glad to have you both here with us today. I felt it was quite appropriate to have the university kind of speak to what's happening in the state of Alaska for this Computer Science Education Week. So I really appreciate you both taking the time to join us today. We'll start with our first question, Kenrick. If you could just kind of describe your background in computer science, maybe what was AI back then compared to what it is now? Were they just not as good algorithms, or I'm curious to hear more about your background.
Yeah, so I could say a little bit about some projects I worked on as a grad student. So my thesis was this project where we took data about the space telescope, and so this is a project for NASA where we wanted a telescope operator to be able to ask questions like, "What should I do if this compressor fails?" And so we made this system that could answer those kinds of questions, and we built it all by hand. So we came up with all the knowledge that you would need to understand this space telescope domain. And then we had it parse through manuals, and it was able to do like a question answering, like you would get today if you asked ChatGPT these same kinds of questions, except we manually built the model, but we did parse it from the text. And it was really good at this one very specific thing with the space telescope and nothing else. And so the criticism of the time was that things did not scale very well, and this one didn't really scale because we hand built it. So nowadays, machine learning would learn this stuff on its own. So that's kind of where the AI has gone over the last 25 years. And anyways, I worked at various places, including Intel and a startup, and of course higher education.
Great. And how about you, Frank? Your background in computer science?
I came at it. I was really excited to study computer science and math as an undergraduate, and then actually did my graduate work in geography. And so I pitched myself as a computational geographer. And so I come at it with the idea of just trying to apply a lot of the existing data sets that are out there. And so I have a specialty in satellite imagery and using remote sensing data analysis. And of course, you can imagine the terabytes and terabytes of data that are being generated every day as these satellites fly overhead. But of course, all that data is useless and meaningless if it's just being archived somewhere. So my goal is to try to dig into it and get some value from that imagery and be able to understand in a more human sense what's going on the ground. What changes are we seeing? And so for my graduate work, I actually studied the conflict in Bosnia Herzegovina, and there was so this was the conflict from 1992 to 95. And as part of the war, there was quite a bit of ethnic cleansing, and people forced off their land, and also landmines laid. And so this, in combination with things like the collapsing economy, caused land abandonment. And so I was focused particularly on agricultural land abandonment. And so at the time, I would order Landsat scenes, and so I would get these physical, DVDs of one Landsat scene. It'd be like 540 megabytes, and I'd have to manually process it and manipulate it. And now there's all sorts of tools like cloud computing, where I can use, for instance, this Google Earth Engine, which is the platform that Google Earth is built on. So many of you are familiar with using Google Earth, but Google Earth Engine it gives you the access to the behind-the-scenes data sets, and they keep adding more and more to them. So now I can basically get access to the entire Landsat 8 archive and the Landsat 9 data and older platforms as well, and be able to, rather than just, I basically did a before and after look at the effects of the war in Bosnia, but now it'd be much easier. You can look at a per pixel basis, every valid pixel for the entire time period, and run all sorts of statistical and data analysis on those sorts of data sets. So, pretty exciting, the kinds of changes that have happened over the last 15, 20 years in that domain.
Amazing. Do you think projects like that, given the new technologies, if you had the time and opportunity, would you revisit it again with the new
I actually
technologies?
did about 5 years ago or so. I actually did go back, and it was part of, I went over to Dublin, Ireland for a Google Earth Engine conference, and as part of that, sort of did a hackathon type event where we used Google Earth Engine to analyze the same area that I had studied. And there's different ways that you can look at sort of a time series analysis to detect changes. So I did a little bit of that, and it didn't end up going anywhere further in terms of publishing the results. But yeah, that's definitely pretty impressive, the kind of work you can do with that environment now.
Yeah, absolutely. Kenrick, I'm curious, do you have any projects that you're currently working on?
Well, as an administrator, I don't get to work on quite as many of the coding projects, although I still tinker around just personally. For example, Frank can probably attest that sometimes he needs to email me a couple times before I do something, and my inbox happens to have like 80,000 emails in it. And so I realized, hey, I actually do things when someone reminds me. So I made like a little AI bot that will every day, at the end of the day, it goes through my emails and tells me if there's something I need to take action on. And so that's actually been kind of helpful. But otherwise, most of the projects I've been working on are kind of administrative. So we have a robotics club, and I've been helping to run that. It's an AI and robotics club, and so those are students that are, it's a safe place where they can explore AI and at all different levels, where you're just getting started or you're deep into coding. And then we've got a couple of grants from NSF. One of them is around building partnerships with the community. And so we've solicited projects from the community and have students and faculty are working on them that are AI related. And then we're doing things like AI outreach we offered summer camps in AI for middle to high school kids last summer. And we did a class for adults over 50. That's kind of AI literacy. So those are most of the projects I've been working on lately.
That's great. And how about you, Frank? Any current projects you're working on?
Yeah. Of course, I've got some administrative responsibilities, not as many as Kenrick as chair of the department, and so I still am able to do a fair amount of research. And so recently I've done projects using computer vision to automatically detect invasive species. And so, for instance, there's this aquatic invasive species known as Alodia. And it can clog waterways and cause all sorts of problems for salmon and spawning. And so it's transmitted, one of the ways it's transmitted is via float plane. So we have a project where we mounted GoPro cameras on the struts of the float plane and pointing at the rudders, and generated a few thousand images of that, and then went through and labeled which ones had vegetation entangled on the rudders, and then trained multiple AI and machine learning models to automatically detect that vegetation. And some of them used existing models and did some refinement of those models, and some generated new models using tools like convolutional neural networks. And so that was one project I worked on recently. Another project, I used satellite imagery to automatically extract coastlines from Alaska coastal areas, with the idea of trying to then model erosion into the future. And so that's an ongoing project that actually we've teamed up and with something called the Google Summer of Code, where we actually hire students from around the world. Unfortunately, with this project, we actually can't hire UAA students, but other students can come in and work on this project through the Google Summer of Code. And then I'm part of a large NSF F-score project between folks in Fairbanks and Juneau and at UAA here. And so this is a large project trying to look at changes in the Gulf of Alaska and looking at mariculture in particular. And my portion of the project is focused on changes in ocean and estuarine water environments that might affect salmon, ability to find prey and then also avoid being eaten. And so we're looking specifically at turbidity of water surfaces using satellite imagery. And again, this is an ongoing project, but I've got a couple of undergraduate students that I've hired to help out and work on this project. And so it's one of the opportunities that students have when at UAAs to be able to work with different faculty on these kinds of research projects and get that kind of research experience.
Yeah, wow. Hands-on learning opportunities right here in our backyard. That's really incredible. I'm curious, looking at the program at UAA, and really any program that's kind of closely related, for those who are interested in pursuing a career in computer science, or potentially just any career that uses technology, which is just about any, what are some of the things that your department offers for prospective students? Are there students who really are interested or might have an inkling and want to learn more? Kenrick, if you could explain a little bit about the program and what it offers.
Yeah, so we have a Bachelor's of Arts and a Bachelor's of Science in Computer Science and a Bachelor's of Science in Computer Systems Engineering in the College of Engineering. And then there's some other technology-related programs across campus, but those are the ones we focus on here. And we actually just added a master's degree in AI and data science and engineering. So there's a whole trajectory you could go through. And so if someone is interested in those fields, as a high school student, then I'd start by saying, like, there was a ton of, well, of course, you could take some classes in high school, of course, but there are so many online resources that you can experiment with that it's really, the sky is the limit. There are so many things that you can play with. So I definitely encourage folks to experiment with all those online systems. And then also to join like a robotics team or hackathon to have like some purpose, and also to work with people. There's that stereotype of the coder alone in the dark basement, but really most projects are with the team of folks, and interacting with people is part of the job and part of the fun. And so joining one of those teams or competitions, I think, is a good way to get some more real world experience, and also focus what you're working on.
Yeah, it's a good point. And a lot of schools in the state do offer robotics competitions, but there are also a lot of small schools in the state that don't have those competitions, and students who I'm sure are yearning for the opportunity to build and play with robots. And that's certainly something in my position. I hope to help support those students in those areas. But I like the idea of the hackathon, and perhaps that's something that we could look at collaborating on and inviting students to participate in a hackathon. I think that would be really fun. Frank, what is the importance? So you're talking to students. What is the importance of digital literacy in our current age? Why should students know how to use computers, let alone program? Maybe not all are going to become programmers, but why should they learn how to use computers?
Well, for one, they're ubiquitous. And so I think that even students who have no interest in going into computer science or data science or any technical fields like that, I mean, I think there's value in everybody taking an introductory computer programming class. And of course, I'm completely unbiased in my opinion there. But the reason I think is to understand at a more fundamental level, like what's going on and how a computer thinks. And really to understand that ultimately, I used to be able to say this with ease, that computers are dumb. And it's still mostly true. They're still amazing. That they're even more amazing now with some of the things they can do. But even with your latest AI, it still does really dumb things sometimes and says things that are really wrong, right? So it's not really thinking in any way close to the way a human thinks. And so I think being able to understand that at a more fundamental level and understand, like, if you're programming a computer, you need to be very precise in your instructions that you give. And there's no wiggle room there, that the computer's not going to think like, oh, I know what you meant there. You have a little typo there, but it's cool. I'll let it slide. And I think that also just helps. I'd like to think at a more fundamental level, like when something does go wrong with your computer, it's easy, I think, for a lot of people, maybe more so an older generation, but I think even there's lots of other people that are, it's like if something goes wrong on their computer, they just freak out, they'll internalize it, they'll think they did something wrong. Whereas, most of the time it's just, yeah, some weird setting that some, computer programmer put in, and that they've got to go figure out and change it. So I think that's one of the real benefits of just having that knowledge.
Absolutely.
If I could tack on there a little bit. So I mentioned that that email agent that reminds me on task. So most of that, I was able to build just kind of connecting flowcharting things, but there's a little bit of code in there, not a lot, but just enough where if you hadn't taken, a CS1 programming class, you wouldn't know how to do that. And so having a little bit of coding knowledge really does go a long way in what you can do.
Yeah, and I think it used to be that to get into computer programming on your own, you were kind of asking about what students can do kind of on their own. Like it used to be a pretty big hurdle and pretty big bar, I think, to get into it, and you really maybe had to be a real geek, stereotype to do it on your own. But I think the bar to entry is so much lower now that if students did just want to start goofing around, there's so many tools and resources online that they can track down and dig into, that you can really go pretty far on your own. But of course, there's also the downside of just going on your own is there'll be big gaps in your knowledge base. And so that's one of the benefits of doing a full dedicated, programming computer science, is it fills in a lot of those gaps, which is really necessary, especially when you start thinking about developing systems and being able to think in terms of systems and processes and algorithms and how these fit together.
Yeah, absolutely. Last question for you, gentlemen, and Frank, I'll hand it to you first, just in the event that you need to step out. Um, what do you see as the potential and future of computer science in the state of Alaska and beyond?
Well, I think a lot of people and parents and students are hearing about AI, and I think for some people that's scaring them away from computer science, thinking like, oh, why should I study that? AI is going to do it all for us, uh, and that certainly is not the case yet. And I don't think it's hard to say ever, but there's still lots of room for human imagination and creativity and problem solving, and I really view a lot of these AI tools that we're seeing as ways to augment human ability and increase productivity. And certainly in some places like Silicon Valley, there's been some layoffs that make headlines. But when thinking about it in terms of the state of Alaska, our sort of tech industry is a little bit different, and there's still lots of employers in the state, from folks at GCI in terms of telecommunications. There's Resource Data Incorporated. There's banks like Global Credit Union, the Alaska Railroad. There's other agencies within the state of Alaska, whether or not it's ADF&G or Department of Transportation. But our students, so far have not been having trouble finding jobs and employment in the industry. So I think, computer science in general, we've got a long history of cycles, the dot-com boom and bust. And so I think there's a fair chance that students entering the field today will actually have even better job prospects in 4 or 5 years, in part because there's been a bit of we have seen a little bit of a dip in enrollment recently. And so I think in 4 or 5 years, there's a fair chance there'll be another tech boom or some other, great thing. And so then there'll be, fewer students vying for all those jobs. So, yeah, I'm typically optimistic about these things. And I remember back in the mid 1990s when I was getting my degree in computer science, people talking about how programmers were going to put themselves out of a job. And so that certainly hasn't happened in the last 30 years. And I don't expect it to happen anytime soon.
No, absolutely not. Kenrick, over to you.
Yeah, I'm pretty
Potential
optimistic as well. So, the AI coding tools today, they're pretty good, but let's say if they're like a level 5, so if you're a graduate and you're below level 5, then maybe you might be worried about jobs. But as an assistant, so if you have your, say, computer science degree and you're using these AI tools, then your productivity can be like level 20 or something, way above what just the AI tools can do today. So that's where I see the field going, is using your brain in conjunction with these AI tools. And in Alaska, while I don't think we'll be like a Silicon Valley or Silicon Arctic anytime soon, just because we don't have the critical mass for that, there is still a great need from industries and nonprofits and government for all sorts of software. We see it all the time. And we also recently did a survey about engineering firms using AI. And so these are all opportunities where if someone comes out of a degree program in some of these technology fields like computer science, there are definitely lots of opportunities to apply it to existing industry, government, nonprofit right here in Alaska.
Yeah, and I would say the skill set you learn going through those programs, yes, you could do computer programming, software engineering, things like that, but really you get so many more skills and abilities on top of that. Like you had said, the collaboration, the ability to work with others, the ability to recognize problems and identify potential solutions to those problems, and using technology to be creative means perhaps in a future job you wouldn't even touch a line of code. that you would just be able to orchestrate, solution management or supporting teams to do that. So I think there's a lot of potential. And you say it's not the Silicon Valley of the Arctic, but I say not yet, because I am bound and determined to try and find ways to make that happen. Awesome. Well, any last thoughts or ideas before we wrap up?
Well, I think one thing I was going to say, just to build on that, is I think one of the things that's easy to mistake is that computer science is computer programming. And so that's really not the case, right? Programming may be a component to it, it's a tool for it, but computer science is much more than coding, right? It's about understanding systems and design and algorithms, and again, being able to work with people in a group setting. And so, yeah, it's good to think beyond just that tool of programming.
Absolutely.
And I'll just say, of course, we love kids to come into our programs, but for teachers as well, we're happy to work with any teachers that would like to discuss these topics or see where we could help.
Awesome.
And actually, one other quick thing I wanted to mention. I know Kenrick already mentioned things like the coding camps and the Summer Engineering Academy, but also in terms of high school students, if they're interested, they can take AP classes, but also more commonly is the Project Lead the Way classes. And so those PLTW classes, if students score well enough, they'll get direct college credit as part of our program.
Yeah, we'll include more information on that for the students, and hopefully get more districts across the state to be able to offer Project Lead the Way classes. Well, gentlemen, I appreciate both of your time and efforts. Certainly we'll have the link on this video for those who want to learn more about the Computer Science and Engineering program, but you could also search uaa.alaska.edu for more information on those programs. So again, we really appreciate it, and hopefully we'll be working together soon for another project to support those students who aspire to go into computer science. So thank you.
Thank you.
Okay. Yep. Thank you. Appreciate
Awesome.
it. Bye.
All right. Thank you, gentlemen. Stop recording.